Perfect cubes and perfect squares is what we are going to see in this lesson, but please don't forget to subscribe to the channel. Now, if a quadratic expression f of x is a perfect square, this is expression is a perfect square, then f of x, this quadratic expression is given by we square a linear function. If it's a cubic expression, say b of x is a perfect cube, then b of x is equal to the linear function cubed. Now note, this a is the square root of the coefficient of x squared in the given polynomial of f of x. And k is the cube root, because we are dealing with cube, the cube root of the coefficient of x cubed. Let us now find the value of b if this is a perfect square. Now so here, this my coefficient of x squared is 1. Square root of 1 is 1. We take the positive. So that here my a is 1. So what we say x. Now my a x plus. Now here I'm saying I have a b. I can use any letter. So I can send it to bc squared b equal to the polynomial we have. Because it's a perfect square, it should hold for that condition. Now so my a is 1. So meaning now I have x plus c squared equaling to x squared plus 9. Let me expand this. When I expand this, I get x squared. This and this then by 2. Then plus c squared equaling 2 plus 9. Now after that, we compare coefficients. So if we compare coefficients, the coefficient of x squared this side is 1 and this is 1. That's why that's the use. So if we compare this for x squared and then for x, so now our 2c is equaling to this side we have a b. Now when we compare for the constants, so our c squared is equaling to 9. So now from there is no any condition on the b. So if you get c, our c will be plus or minus 3 if you get the square root of both sides. So to get now the value of b here, so our b here is 2c, which will be 2 into ours we have 2 values. So here our b can be now a plus or minus a 6. So that is if you don't put any condition on the value of this b. If they say b is positive, then we shall take positive 6. If they say b is less than 0, this one means it's negative. We have used now b as negative 6. So always be careful when they put their conditions. Then this one, if k is, find k if this is a perfect square. So now instead of our solution, we have 4y squared minus 24y plus k. Now we need the value of a. We said a is the square root. A is the square root of the coefficient of y squared. Now this one is the highest degree. This one is x, this one is in y. So our a will be now the square root of 4, which will be a 2. We take a positive square root. So meaning I said let now my ax plus b squared b, the whole of this 24y plus k. Now from here, my a is 2 from here. So you say I have 2x plus b squared 24y plus k. Can we expand this when I square this side? Sorry, this is because we are dealing with, we are in y, this one is y also. Because we are in y, not in x. So sorry for that mistake. So when you square this, you get 4y squared. This and this then by 2 shall be having now 4by and plus b squared equaling 4y squared minus 24y plus k. Now from there, that's the use. That's that always this is equaling to that. That's why you get a is always the square root of the coefficient of the highest degree if you are dealing with quadratic equations. So now from here, you see compare. If you compare now y squared the coefficient is the coefficient there 4. Then for y, so this side we have 4b, the other side we have negative 34. Divide through by 4, our b becomes a negative 6. So when I compare now 4, y power 0, the constant, this side I have b squared, this side I have it as k. So now I need the value of k. So that my b is negative 6 squared equal to k, and so that my k will be 36, and that will be the answer. Now this understanding the polynomial is cubed. The thing that n is less than 0. What I should do is that now in my solution, I say let, now this one is a cube, so plus b, now power 3, b, x cubed, this is squared, then plus 3x plus n. Now, we said a is a cube root of this coefficient. So said my a is going to be a cube root of 1, which will be a 1. So here I have now 1x plus b power 3 equal to this. Can you expand it? When you expand this, you get. Now, here you can expand this, you can say x plus b squared times xb. But we said that you can use the Pascal's triangle as we've seen in previous lessons. So when you expand this into the Pascal's triangle, this will be x cubed plus 3x squared b plus 3x b squared then plus b cubed will be equal to now this. You can expand it slowly at your own pace. Now if you compare coefficients, now this one is that for x cubed it's 1 and 1. Then for x squared, the coefficient this side will be 3b, then this side it will be a negative n. Then if you compare x only, this side we have 3b squared for x, 3b squared for x, then this side we have 3. Then for constants, this side I have b cubed, this side I have n. Now, from here, you can use to get the value of b from here. So here, if you divide here, is that my b squared will be 1. And if I get the square roots, my b becomes plus or minus 1. As simple as that. So if my b is plus or minus 1, they told me that from here, n should be less than 0, meaning n is negative. So if n is negative, I should take therefore the value of b is negative 1. Why? For n be less than 0. So for n be less than 0, if I take n positive, it's going to be positive. But here the thing that n is negative. Less than 0 means it's negative. Greater than 0 means it's positive. So this means n is negative. So the value of which is going to give me a negative, and I put it here, is the one which is going to be negative. So from here, my n is b cubed, which will be negative 1 cubed. And so my n is when you cube the 1, get a 1 and it retains its power. Now we have got the value of n. What about n? From there, our negative n is equal to a 3b. So our n will be divided by negative 3b. So our n will be negative 3 into. We took our value of b as negative 1 for the reasons you know now. And so our n is going to be 3. As simple as that. So the condition is always be careful. Don't expect here we have two values, but for n to be less than 0 means that when I choose that number I've got, it should be negative. So when you choose positives, we get positives. When you cube negatives, we get negative. That's why I chose this b to be a negative 1, and it's the turning point of the whole question. This is the value of n, this is the value of n. That's how you handle that numbers. Now in some questions they can say, if this is the perfect cube, show that this is this. You use the same idea, you eliminate what they don't want. That's it, members. I wish you well.